Okay, let's unpack this. We're taking a truly deep dive today into a really specialized piece of architecture, the AWS Calendar Invite Server.
Yeah.
Now, sending an invitation sounds simple, right? Like click a button, email goes out, done.
Seems trivial.
But when you're building a system to handle this at, massive scale, enterprise scale, the plumbing underneath gets seriously complex.
Oh, absolutely.
So our mission today is really to understand the two main, almost opposing actions this system performs. How it gets the data in the ingress, and specifically how it prioritizes disassembly first.
Right.
Before it even thinks about assembly and egress sending the final thing out.
And what's cool here, I think, is that we're looking past just like abstract ideas about microservices. We're seeing how they apply these principles to a very structured, very common thing. Mm-hmm. The calendar invite, like iCalendar or vCal format.
Standard stuff.
Totally standard. And our sources basically give us the blueprints for this specific AWS stack. We're kind of offering you a shortcut here, a way to understand why on earth they chose to break down a perfectly good standardized object.
Okay, so let's make this concrete then. Our mission,
right,
trace the exact sequence from, say, an organizer dumping a huge batch of events into the system.
Yep.
All the way to a single personalized invitation actually being sent out.
Yeah.
And we need to really look at why those specific AWS services like, Lambdas and SQS are doing the specific jobs they are in that sequence.
And we really have to start with that first big architectural choice. Disassembly, it feels backward, doesn't it?
Yeah, a little bit.
Why add overhead? Why break down this clean, predictable data block before you store it or send it?
Okay, so why?
Well, the simple answer is scale. And efficiency. Think about it. If they just stored the whole compiled iCalendar object for every single potential invite, storage gets really repetitive, really fast. And trying to query for specific things like, find me every event happening in Arizona next Tuesday becomes super inefficient if you have to parse millions of text blobs. So by breaking it into components early, they optimize for retrieving specific pieces and handling these massive batch operations later. That modularity, that's really the key insight we're chasing today.
All right, let's follow that data trail then. Starting with ingress, getting the data in, the starting point is always the organizer, right? They're outside the main system.
Yeah, usually.
And they're sending the raw event data, could be dozens, maybe hundreds of events, to just a common email address, a configurable one. The source uses create.com as the example. That's like the dedicated funnel for batches.
And you see the scale problem right away. I mean, think about a Major League sports team, for instance. The use case we have talks about an organizer maybe managing like 20 events for the Arizona Diamondbacks in a short window.
Okay, 20 sounds manageable.
But that's just a snapshot. That organizer might upload the entire season 200 games in one go. And if this system is for fan communication, those events might need to go out to tens, hundreds of thousands of season ticket holders eventually.
Oh.
So that initial batch upload creates this huge instantaneous burst of data hitting the system all at once.
That burst definitely needs elasticity, which brings us nicely to the ingress level, the disassembly part. The sources call this a full calendar invite disassembly process, an ETL pipeline, extract, transform, load. This was the raw iCalendar text files get, taken apart.
And this is the really critical transformation point. The AWS pipeline kicks off with SES, the simple email service.
For receiving the email.
Exactly. SES handles getting those emailed calendar files, but because that Diamondbacks batch or whatever creates that sudden spike, the data immediately gets pushed into SQS, the simple queue service. SQS is just crucial here. It acts as a buffer.
Like a shock absorber for the traffic.
Precisely. It smooths out that spike, make sure the rest of the architecture doesn't just fall over.
Okay, so SQS holds the raw payload, waiting. Then the Lambdas jump in, the ones specifically for ETL. What are they doing? They're not just moving files around, right?
No, they're the engine. They're parsing the iCalendar standard, RFC 5845. They're ripping apart that really structured text block.
Which has everything, right? Recurrence rules, location, attendees.
Everything. And converting it into separate, easy-to-search key value pairs. So instead of one big text blob per invite,
you get lots of little pieces.
Yeah, you might get individual rows or items in a database for the event name, the start time, the location, maybe even each attendee's specific RSVP status eventually.
And the result of all this complex work, these components, these pieces of the invite, they get stored primarily in DynamoDB.
That's the main operational store, yeah.
And this seems vital. Every single piece of that disassembled data, maybe across hundreds of database entries for one original invite, is tagged with the correct UID, the unique identifier. That UID is the golden thread, right? It keeps all those broken pieces functionally connected.
Absolutely essential. Without that UID, it's just a pile of unrelated data.
Okay, moving to storage. Let's talk about why DynamoDB is the primary choice here.
Right. So this isn't really relational data in the traditional sense. It's high volume, potentially high velocity data. And the main thing you need is super fast lookup based on that UID.
Find all parts of invite hashtag 47,000 now.
Exactly. DynamoDB gives you that scalable, predictable performance for key value lookups. It's built for that kind of access pattern at scale.
That makes total sense for speed and scale. But let me push back just a little, thinking about transactional stuff.
Okay.
Doesn't breaking the invite into potentially hundreds of pieces and sticking them in a NoSQL database like DynamoDB, doesn't that kind of sacrifice transactional integrity? Like atomicity, are they basically trading safety for speed?
Oh, they are absolutely trading traditional relational integrity for that raw speed and massive scaling potential. That's a very conscious architectural choice.
A calculated risk then.
It is, and they mitigate that risk, or at least part of it, by keeping a copy of the raw ingested data in S3. S3 acts as the durable, cheap, long-term archival storage.
The backup.
Kind of the ultimate backup, yeah. If something goes wrong with the operational data in DynamoDB, or they need to rebuild a huge data set from scratch, S3 is the reliable snapshot they can fall back on. It's the safety net.
Right. Okay, safety net in place. And coordinating all this storage and retrieval is the API gateway. The sources mention 9 APIs hooked up to this gateway. 9, just for calendar invites.
Yeah, 9.
That sounds like a lot. It signals a massive degree of specialization, doesn't it? What on earth are 9 different APIs doing?
Well, that number 9 is actually really revealing. It shows the modularity and, frankly, the potential complexity they're managing. If they just had one massive API.
You'd be slow and fragile.
Probably, and hard to update. So instead, they've split the responsibilities. Think about everything you might need to do with a calendar invite system beyond just sending the initial invite. You need an API for maybe checking the status of the initial creation or ingestion. That's one.
Right.
Maybe one for managing audience segments. You know, deciding which Diamondbacks fans get invites to which specific events.
Targeting.
Exactly. Then you definitely need one for compliance and auditing. Did we send it? When? Who to?
Makes sense.
Maybe a couple for handling metadata updates, like changing an event time or location without having to rebuild the entire invite object from scratch.
Just update that one component.
Precisely. Another for retrieving status updates, like RSVPs coming back in.
Yeah.
Opened, unopened, accepted, declined.
Okay, that's 6.
And then, of course, the actual API call to trigger a single send. So, yeah, you can quickly see how you'd get to 9 or even more specialized functions.
And that partitioning, that breakdown, that must explain the user experience. The data gets shown in the event organizer dashboard.
Right.
The user isn't seeing raw DynamoDB rows. Those 9 APIs are querying the stored components, processing them, and then presenting them logically on that dashboard. So the organizer can, say, use one API call to instantly see the RSVP status for everyone invited to Tuesday's game, without needing the system to reassemble the full iCalendar file first, just for that view.
Exactly right. And that's where the modularity really pays off for the user experience. It feels fast because the system only grabs the specific little pieces via the right API needed for whatever the dashboard is showing right then.
Okay, now let's flip this whole process. We've got the pieces stored, disassembled. How do we get back to a useful finished product? The egress side.
The reassembly phase.
Yeah. And the trigger, the sources say, is the single event invitation send API.
Right. So this command usually starts from that dashboard we just talked about. The organizer maybe loads up a specific recipient's email address.
Just one email?
Just one, maybe adds a personal note, clicks the send button or whatever the UI is. That action, that click, is the cue for the system to fire up its reassembly engine.
And that engine is explicitly called out as Lambda number 2.
Is that Lambda 2?
Which is different from the ETL lambdas doing the disassembly during ingress. This one's specialized for output. What's its job? What's the workflow?
Lambda 2's job is pure reconstruction. It takes that single recipient email and the required event UID.
The golden thread again.
Always the UID.
Yeah.
It goes straight into DynamoDB, pulls all those separate components associated with that UID, the title, the time, location, recurrence rules, attendee list, everything related, and stitches them back together.
Into what?
Into a single, syntactically correct iCalendar structure, just like the original standard requires. It's basically running the ETL process in reverse, but only when needed on demand.
Huh. So they only pay the compute cost for putting it back together right at the moment they need to send it.
Exactly. That's the core trade-off playing out. Minimize the ongoing storage complexity and duplication.
By introducing these periodic, maybe intense compute demands just for sending.
Right. Once that invite is fully recreated, properly formatted to the iCalendar standard,
Then it goes out.
then it gets sent out to that single specified email address, probably using SES again, or whatever email delivery service they have configured.
The efficiency there is in the delay, isn't it? They don't pre-generate, say, 10 million compiled iCalendar files for that big Diamondbacks season launch just to have them sit there in storage.
No way. That would be hugely wasteful. They store the components once, then they use Lambda 2 to generate the final personalized email only when John Smith needs his invite.
Which also means if a detail changes, like the game time gets pushed back an hour,
You just update that one-time component in DynamoDB.
and you don't have to regenerate and replace 10 million thread files.
Bingo. Much more efficient for updates, too.
Okay, and there's one last piece, a feedback loop after delivery. The sources mentioned that after the invites go out, data comes back to the API gateway. Something about UIDs being summoned, collected, sorted, and stored back into DynamoDB. What's that about?
Yeah, that's crucial for closing the loop. The system absolutely needs to track what happened after sending. Delivery success, bounces, maybe even tracking opens or clicks if they have that capability, and definitely RSVP status coming back later.
Status tracking.
All tied back to that specific recipient and that specific event UID, so that incoming status data flows back through the API gateway, probably hitting one of those specialized status update APIs we talked about,
Right.
to update the relevant components in DynamoDB. So now, back on the Event Organizer dashboard, they can instantly see 78% delivered, 5% bounced, 12% accepted for that specific event.
Because the componentized status data in DynamoDB got updated quickly.
Exactly. Keeps the dashboard view current without needing complex reporting queries across massive logs.
Okay, so if we zoom out and look at the whole loop,
Yeah.
ingest, disassemble using Sescos Lambda, then store those components in DynamoDB, then reassemble on demand using Lambda 2, send, track status.
Yeah.
What we've really seen is this incredible commitment to modularity.
At every single step.
They broke down the invite, maybe counterintuitively at first, but they did it to achieve maximum flexibility and scale in the long run.
And that modularity, that core decision, leads us right to the biggest takeaway from looking at this architecture, I think.
Yeah.
What does this whole approach, prioritizing disassembly for storage and reassembly on demand for sending, what does it tell us about managing complex but standardized data objects like calendar invites when you're operating at a really massive scale?
It tells me that sometimes, maybe often at scale, the simplest way to manage a complex finished product is actually not to manage the finished product at all, but its pieces.
Right. And it raises a really important question for you, the listener, maybe for your next project. When you're dealing with large volumes of predictable data that reliably follows a known format, whether it's iCalendar or maybe some standard JSON schema or XML, is it always better to maybe incur that upfront compute cost of disassembly and the later cost of reassembly in order to manage the components instead of the finished thing? If your main goals are rapid modular retrieval, efficient updates, and massive scale, well, the answer from this AWS Calendar Invite server seems to be a pretty resounding yes.
Definitely something to mull over when you're designing that next database schema or API structure.
Exactly. Food for thought.